Good afternoon, we are now live.
Good afternoon and welcome to this webinar organized by the FTTH Council Europe titled Signal Quality and Performance Monitoring in FTTH Networks. My name is Vincent Garnier. I'm the Director General of the Council and I will be moderating this session organized by our member Axiros. And before we get into the more detailed presentation of the session, I would like to walk you through some initial slides, starting with a brief presentation of our organization, the FTTH Council. For those who are not familiar with it, this is a non-profit trade association founded 20 years ago with the objective to promote full fiber networks as the most future-proof and sustainable access network technology. We are representing the entire ecosystem around FTTH network, vendor, operator, investors, and we are developing a certain number of activity, producing reports, organizing advocacy work, favoring networking between members, educational content, and this series of webinars is part of that effort to communicate with the ecosystem on best practices, and in this case, very much technical oriented. You will have the opportunity, since you registered to this webinar, to be invited to next session, which are really there to enable you to have access to all aspects of FTTH in Europe from a variety of angles. A few housekeeping items. This session is recorded, so you will have access to the replay after the session. We will send that to all participants live, but also to all those who registered to the session and could not attend. We will also share the deck, which is going to be presented by our speaker of today. And please do not hesitate to ask questions. You can use for that purpose the question box, which appears on the panel control of your screen. And Pavle, our speaker, will dedicate some time at the end of the session to address these questions. So here is our speaker. Pavle Skoshir is a technical account manager at Axiros, an expert in signal quality and performance monitoring for fiber network. And the objective of this presentation and what you will take away is really a better understanding of how FTTH network can be monitored with an approach based on standard, deep diving into concepts like health indexes, and also a view on how Axiros platform can be used for testing and also leveraging artificial intelligence in some concrete cases. So without further ado, I would like to give the floor to Pavle, who will introduce further the details of this presentation. Pavle, the floor is yours.
Hi, thank you, Vincent, and hello to everyone from my side as well. In this webinar, I will present, as already mentioned, a multi-vendor and multi-protocol approach that we are using for monitoring in FTTH networks. So this is the outline of the webinar. So I will be here mainly talking about the operational phase in FTTH network deployment. So when the network is set up and customers are connected, signal quality and performance monitoring is one of the challenges in this phase in network operations, while other challenges will be also briefly mentioned as well in the introductory part before we dive into the most relevant KPIs and some customized metrics that we introduced to monitor the health status of the ONTs. But before we start with the presentation, we would like to know a bit more about the background of the audience in order to be able maybe to adapt the pace of the presentation. So please do this poll that we prepared.
And Pavle, with this, you will know who you talk to. We have more than 120 participants live right now, and it's always good to understand their profile and where they come from.
Exactly.
It's I think we have 60% of the audience having now voted. I give them a few additional seconds, so we have an accurate representation of the participant of today. And not to waste too much time, let me bring the, I think we are nearly there. I'm going to share the results. Things are relatively stable. So we have 35% working for a telecom operator, a bit less for a vendor or service provider, 15% in consulting, regulatory activity, and 20% in different functions. So that gives you a snapshot of who you have in front of you.
Okay, great, and thank you for doing this poll. So yeah, majority is a telecom operators, and yeah, this topic will be then most suitable for you to see how are we doing, what is our approach for the network performance monitoring in GPON networks. So as I mentioned in the operational phase of the FTTH deployment, signal quality and performance monitoring is one of the most important challenges. We will discuss it in greater depth during the rest of the presentation. Some additional challenges also include network security, which is a very important topic in every communication network, and special attention in this area needs to be paid to protecting against eavesdropping, spoofing, and unauthorized access. To ensure reliability, it is very important to contain mechanisms to efficiently detect and resolve network issues, and also to mitigate the impact of some environmental conditions on the equipment and some physical damage which can also happen on the infrastructure. Additionally, a network also needs to be designed in a way that it is upgradable to a higher capacity when the demand for network usage rises. So it is necessary to be able to detect when is the proper time for doing those upgrades. And for interoperability, it is necessary to ensure seamless operation between components which are usually provided by different vendors. The signal quality and performance monitoring approach that we will present today uses well-defined protocols like SNMP, defined by the IETF, and TR69 and its successor TR369, defined by the Broadband Forum. Here in our approach, those protocols, so TR69 and 369 protocols, use well-defined data models, which is also very important, so that the information that we would like to get from all the devices can be represented in a structured way that can be then easily parsed and used for some post-processing and extracting some valuable information. And those KPIs that we are extracting are from two types of network elements. So from the OLTs, so optical line terminals, and from the ONTs, optical network terminals. So from those two types of the devices, we are extracting all the information that we need to estimate the status of the FTTX networks. Signal quality and performance monitoring mainly relates to ensuring that there is a suitable power level set for the expected fiber length and split ratios, and that there are no signal strength reductions in the network. unexpected signal quality and performance values might be an indication of connector loss due to some poor or dirty fiber connectors, some splicing loss due to misalignments in fiber splices, and some physical bends or micro bends on the physical cable. So the focus of this presentation is to present you the most relevant KPIs that we can acquire by using the aforementioned protocols, and also to describe the most relevant relations and calculations we are using in our products and deploying at customers. So the detection of the mentioned unexpected issues and changes in the network can be done by monitoring receive and transmit power levels on the ONTs and on the OLTs, and also by then comparing those values. So if there is some misalignments between those values on the ONTs and the OLTs, that might be an indication of some issue on this connection between those two elements. So while deploying the network or updating hardware or software, these values are always configured and adjusted. But because of also some degradations of laser diodes, possible inconsistencies in manufacturing, it is necessary to monitor these values over time. So during the regular operation. So this comparison is the one important let's say thing that needs to be done in the FTTH deployments. But one thing that is particularly useful is to have an overview of the overall health of the ONT. So this is something that the customers are looking for. So to have let's say one single index which can tell you what is the status of the network, so that you don't need to compare several KPIs, but to have a look at one specific index, which can be like some traffic lights, and say, okay, everything is good, everything is green, there are some issues, so the value could be then signified as yellow, or there is some significant trouble, which can be then also denoted as red. So so it would be something like having a traffic light for the nodes within the network. So within our solution, we wanted to have a numerical value which shows the relation of these aforementioned receive and transmit power values, and therefore we introduced this specific KPI which can be also correlated to the customer quality of service. So we have here this network health index. This is this main KPI which shows you the status of the network, and the values are shown here in our customer support portal. So this is the application which shows you the status of the whole of the ONT. And some most important KPIs and some historical values. So this network health is now one of those KPIs that we are monitoring. Additional KPIs also include this utilization and optical intermittence. So optical intermittence are some fluctuations or interruptions in the optical signal. So for this health, network health ONT health index, we are using different KPIs which are collected both from the ONT and from the OLT. So as mentioned, we are also comparing those values, so those transmit and receive power on the OLTs and the ONTs, and we are also using this to calculate this overall health of the ONT device. For this, we are using different protocols. So usually it is possible to get those values from the ONT, so receive and transmit power. You can get them by using the TR69 protocol, and this is usually done in some specific collection period. So we have some intervals in which we are getting those information from the ONTs, from the end devices. Also, to do this estimation of this health index, we need information from the OLT, so receive power and transmit power from the OLT, and we are getting this information by using the SNMP protocol. There is also some additional information which is taken into account. This is this SFP information about the SFP module. So this SFP is its full name is Small Form Factor Pluggable Module. So this is actually optical transceiver at the OLT. So there are different, let's say, models for this SFP and different levels of this module, which need to be taken into account because some thresholds value do differ based on the type of this SFP module. And also we are taking into account this parameter on the ONT, discarded packet ratio, that can also be acquired by using the well-defined TR69 protocol. So for each of those KPIs that are mentioned in this table from the previous slide, we have some thresholds. So in order to be able to calculate whether this KPI, whether its value is bad, marginal, or good, we are defining some thresholds, and usually those thresholds need to be readjusted for different CPE models for different vendors, and so on. So if you use this calculation, that usually every CPE model, or at least every vendor, would have their own thresholds. And how we usually do it with our customers already have some idea about how should these thresholds be set, and in agreement with them, we are then setting those values for to be used for the calculations. So receive power, transmit power on the ONT, discarded packets ratio on the ONT, and receive and transmit power on the OLT. And each of these values would then have a certain weight. So before we proceed discussing those weights, there is another poll. So which parameter has the lowest weight according to customer ranking? So as I mentioned earlier, we are setting those weights according to feedback from our customers. So the question for you is, what do you think? What is the KPI with lowest weight?
We're
And
having
of course,
maybe 20% of the people voting. I guess that question is much more technical than the other one. So maybe we will not wait until everybody has voted. But so far, it's progressing nicely. Probably we'll end up having more than 50% of the audience voting. And by the way, the audience is growing gently. So I think it seems to be stabilized. I'll share the result maybe now, and you can comment, Pavle. So I don't know if you read that, but we have 35% for discarded packets ratio, and then fairly balanced distribution of the remaining vote between the four other options, but 35% for the discarded packet ratio.
Yes, great. Thanks for the vote. I can then share the results. So this is how we actually set up these weights at our customer premises. So the highest vote with discarded packets ratio was also how our existing customers decided. So this is something which can be customized. So you can also, if you would use this solution, you could say that maybe those values from the OLT have more importance than on the ONT, or whatever logic you might have. So it is possible to adjust those weights accordingly. So then, in order to calculate the overall health of the ONT, we are actually then summing up those weights. For instance, if you would have some X here in the marginal area, you would get 5 points. In here, maybe TX would be here as good. So then you would add 10 points, and you would add all of those weights and divide it with the sum of total weights for each parameter considered good, and then you would actually get a value when you then multiply it by 100, and you would get the value between 0 and 100. So you would get a percentage of this for this network health. So it is a value from 0 to 100. Okay, so this is it about this health index calculation. So as I mentioned, based on this, you can see whether the fiber network quality is satisfactory. So, for instance, if you as an operator would have users on in GPON network, when users are calling in your customer service, then usually they either have issue with the access network or some issue in the home network related, for instance, with the Wi-Fi. And if you would have those indexes, so here this index for the FTTH connectivity, you would see if this is fine. So you would also be able to define some thresholds. For instance, if network health for the ONT is above 80%, then this would be considered as good. But what we are also offering to our customer is a health index for the X-Wi-Fi network, so for the home network. And then your customer service would see, for instance, if the health of the Wi-Fi network is lower, then they would immediately be able to detect, okay, the problem is with the Wi-Fi network, or if this health index that I just presented is in some yellow or red area, then you would say the problem is in the GPON network. So you would immediately be able to see where the problem lies without the need to run some additional analysis. So you would already have results which are ready. Okay, so now in the next part of the presentation, I would like to share some information about Axiros, so about our company which is doing those solutions. So we are a company which is based in Germany. We have a number of offices in Europe, but also in other continents, so US, Brazil, Singapore, and Japan. This monitoring solution for FTTX network is only one solution in our portfolio. What we are also offering is open device and service management, so device provisioning. Also in this area of monitoring, we are offering monitoring and in addition troubleshooting and optimization of Wi-Fi networks, which is quite important to be able to detect and act on those detected issues in the Wi-Fi networks, in the home networks of your customers. And we are also offering some solutions like DHCP, also proactive network maintenance for DOCSIS, some automation services, business edge management, so also management of business routers, not only CPEs, not only customer premises equipment, not only routers at the customer premises. When going back to this area of FTTH networks, so I already mentioned that we are going for this multi-vendor and multi-protocol approach. So we are taking advantage of well-defined protocols, which are supported by the majority of vendors to do the monitoring, but also to do the provisioning of the network elements as well. So for the ONTs, we can do provisioning based on the TR69 or its successor TR369, but also we can do the provisioning of the OLTs. That is done mainly by using the SSH protocol. So we have also one product in which you can define some advanced functions for managing OLTs and not need to log into each of those OLTs separately. And also, as mentioned, there is a DHCP service which can be also used in other networks as well. Additionally, in the FTTX domain, we are also doing some analytics use cases. For instance, we are evaluating the KPIs which influence the speed test results, and we are also analyzing correlations between KPIs. So how can we detect some issues in the network? For instance, how do some deviations from usual power levels, how do environmental parameters like rising temperature and those well-known KPIs like signal to noise ratio and bit error rate, how do they influence the status of the ONTs and the traffic rates? So in this final part of the presentation, I would like to present what are we doing in this analytics and predictions domain. So we have a couple of use cases that we are taking advantage of. For instance, this KPI values prediction. So we have some machine learning models which are analyzing values, so which are analyzing historical values of certain parameters, and based on this, they are predicting how those values will change in future. So here you see this little gap in this line. So here is actually the real value until now, and for the future we have a predicted value for this specific KPIs. Here we analyzed, we did the prediction of RAM usage, disk space usage, CPU usage, and some load average on the servers. One specific parameter, one specific experiment that I would like to present here is the prediction of the speed test results. So we wanted to predict speed test results of the routers which are connected to FTTH network, because speed test execution on large number of devices can be costly. And it's not as fun as those car races and speed tests for cars. So it can be costly to generate all this network traffic, which is necessary to get speed test results, and it is also necessary to have some infrastructure, to have some speed test servers to be able to run those tests. So what we wanted to do here in this area, so we wanted to see whether those KPIs that we already have collected, would it be possible to use them to get predictions of speed test results, so that we don't have to run the speed tests, so that we don't have to generate any additional traffic? Could we predict it? So we run some experiments on three CPE models. So this was done at the premises of one of our customers. So we took different CPE models and collected available information by using the TR69 protocol. So we use get parameter values to get all of those couple of thousand KPIs for each for each CPE model. So here you see this TR98 is actually data model, which this device uses to disclose all this important information. So all this information which is then relevant for the provisioning and monitoring systems. And we also at the same time, so along with getting those all those parameters, we were running the diagnostics. So we were running speed tests and ping diagnostics. So those ping tests are not as, let's say, as resource demanding as speed tests, but we also when doing the test, we also run those tests as well. Then we classified those reports. So based on the output levels of the speed tests and ping tests, we could say whether whether these KPIs have good or bad value. I see here some issues with my screen. I guess, can you hear me well?
Yes, we can hear you very well.
Yeah, we hear you
Okay, great.
very well.
Great, thank you. So yeah, we classified those samples, and in the end, we had for each device we had a couple of thousand snapshots, and we classified them according to some thresholds that we use. For instance, for ping, we use the threshold of 20 and 50 milliseconds, and for download test, we used some other thresholds to say whether those snapshots here are bad, average, or good. And then after this learning phase was done, we were able to see whether we can evaluate the new incoming data. And what was the result of this evaluation is that we were able to predict those speed test results. So here we have results for the speed tests. What was interesting here to see, so we tested some around 10 algorithms here, like random forest voting classifier, support vector machines, decision trees, different regression models. And what was interesting to see is that for different models of the CPEs, we actually got different results of which algorithm provided the best accuracy. And also for ping quality classification, we did this comparison as well. And here we have for some devices the same algorithms have demonstrated the best results, and for some models they were different in those two for those two tests. And then in the next phase, we tried to see what was the correlation. So which parameter, which KPI has the largest correlation with the speed test or ping test results. So these are the KPIs which had for which the correlation value was the highest. This was for the download speed. And we also did the same analysis for the ping quality. So different parameters were came up here as the ones with highest correlation. And the next question for you in the last poll for today is, for which parameter would you assume there is the largest correlation with download speed and ping quality test? So there was actually one KPI for which for all the CPE models there was the highest correlation. So what would you say for which KPI? Which KPI was the
Probably
vote.
while the audience is voting, may I also use that opportunity to remind everyone that you can ask questions. We are moving rapidly towards the end of your presentation and the Q&A part of this session. So any question are welcome. I can see that there are already a few coming my way, but don't hesitate to ask questions to Pablo. I think we still have time to address most of them. And in case we cannot, they will be forwarded to Pablo and he will be able to address them offline. We have close to half of the audience having voted. Looks like there is some pattern taking shape. Maybe a couple of seconds. Okay, let me close and share the result with you. I'm having a 50% for RX power, 31% for transceiver temperature, and then TX power and bias current with 6%.
Yes, so yeah, the audience was correct. So yeah, our RX power was the parameter which had the most correlation with the results. So once the RX power had those at satisfactory levels, then the speed test results were also in those better categories. But what is interesting again here to see, so these were results for the entire data set that we used. But if we analyze it per data model, per CPE model, we actually have some interesting results here. For this model specifically, RX power was the KPI which had the highest correlation. What was also influencing is, for instance, number of hosts. So, for instance, if there is how many hosts are connected to the CPE, bias current, transceiver temperature, and also free memory. For ping, we have also bias current here and host number of entries here quite high. What was interesting, for instance, for this device type, actually free memory value had the highest importance, the highest correlation, while RX power is only at fifth position. We could also do some estimation. So not only those physical parameters influence here, not for instance those events which we would like to predict. For instance, if there is some problem in the network, if there is a bend in the cable, if there is some problem with the connectors. So what was actually here a parameter based on which we can do the correlation is, for instance, hour of the day. So, for instance, when the users are most using their internet connection at home, so this also influenced those results. And here, for instance, here we have transmit optical level as the feature which has the largest correlation for download speed tests, and for ping actually we have again host number of entries. So this parameter which tells you what is actually the load on the CPE. So conclusions for this experiment. So ping test and speed test results prediction can be made based on the collected KPIs via TR69 and 369. So all those values, all those KPIs which we connected were by using TR69 protocol. And what is interesting here is that the most significant KPIs for prediction differ according to CPE model, but we were able to identify, let's say, a list of them, 5 to 10 of them, which do appear in all of those CPE models tested. So before the end of the presentation, I would just briefly like to present you the platform which is used by Axiros for as I mentioned, for both provisioning and monitoring. So we are using multiple protocols here. So TR69 USP is also synonym for the newest version of the TR69, TR369. We are also using we are using DOCSIS. We can monitor DOCSIS networks. We can use SNMP protocol, SSH, for depending on the devices that we are provisioning or monitoring. We are highly adaptable with this regard because we use this multi-protocol approach. For querying, so here when we go to this part of communication with the end devices, we can collect a bunch of information from the devices. What is important here that we have different approaches for monitoring. We have this base monitoring, which is usually done at some intervals, but it is also possible to use real-time monitoring. And here for the real-time monitoring, there are also different approaches which need to be considered. For instance, it is quite costly to monitor the entire network in real time for the whole time, but we are also having some mechanisms which allow you just to monitor a part of the network in real time, and maybe also only to store this real-time information only in these applications which are giving you the overview of the network. So it is not necessary to store all this real-time data in the databases. So we are taking advantage of different approaches here for the monitoring of the end devices, and also for the provisioning part, we are communicating in this direction towards the devices to do some firmware upgrades, to do some configuration changes on a large number of devices, and so on. And here in this part, we are having different applications. So we have support portals, support applications for the customer service. So I've shown one screenshot of this customer support portal for the GPON devices. We also have support portals for the Wi-Fi network, where you can get all the important information about the current status of the network, and also some historical information. And what is also important to say here, that we can easily integrate different AI models. So this experiment was done by using this whole infrastructure. So for obtaining the information and for initiating those speed tests, so we can use this entire platform also for training different models, and then to forward the results even to some external systems. So that would be it for this presentation. Before we conclude, I would like just to say that we will be at the FTTH conference in Amsterdam in March. So if you're interested in what we are doing, feel free to find us there, and we can discuss in more detail about what is of interest to you.
Thank you, Pavle. This is a very wise choice to exhibit at the FTTH conference. So maybe before we conclude and talk about the next webinar, I will share with you some questions which came. First of all, I would like to address a few questions related to the availability of the deck. So yes, the PDF version of the deck will be sent to all participants early next week, together with a replay and a link to the replay of this session. So don't worry, everything will be documented and shared back to you. Now, a few questions. There is one, Pavle, why are you using SNMP and why not streaming telemetry protocol?
Well, this was the protocol which was asked by our customers. So they were already using SNMP, and they mainly wanted the SNMP protocol to get the data from their devices. That's why it is currently used in the system, but it is also possible to integrate other protocols as well.
Okay. I need to read that carefully because it's super technical. According to ITUT study group 12, is there any R&D work done on how to map QoS and these KPIs to the QoE quality of experience on FTTX?
So in FTTX, the approach that we used for this network health calculation was actually done in agreement with our customers. So we didn't go that deep into the standards. What, for instance, we are doing, we also have those metrics, for instance, for DOCSIS networks, where we are using some pretty well-defined cable labs specifications. So if our customers have if they know of some certain standards which can be used here for this network to evaluate this network health, then it would be also possible to use those equations and those rules as well.
Okay. Another question connected to maybe standard. I'm reading that from Ali. For FTTX network, is there any additional parameters in TR181 model which can be helpful but not available in TR098 model?
I would say that more or less the parameters are the same in the model. There is, though, some difference in whether the certain vendors actually disclose all the values that they have in the data model. So, for instance, for some vendors, they do disclose some values in this newer TR181, which are not disclosed in TR098. So I would say that more or less those important parameters, so those parameters related to RX power, they are present in both standards. And also additional parameters include this transceiver temperature, bias current. So these are all present in both data models.
Okay. Are your home performance parameters of your CPE similar to the ONT parameters? And there is a follow-up question, RX mainly, question mark?
So in home network, we also have a specific index. We call it the Wi-Fi score to evaluate the quality of the Wi-Fi network. So this parameter actually takes into account different KPIs. So here for this index for the FTTX network, we take into account those parameters related to GPON network. While for Wi-Fi, we take into account different parameters, so parameters interference. So there, Wi-Fi is wireless network, so we need to take into account interference from other networks. Also, signal quality for the connected devices, for the connected clients. So there are different parameters which we are taking into account for this other metric.
Okay.
So in the end, you would get, by using our solutions, you would get one health index for home network and one health index for the access network.
Perfect. A lot of very precise question to you, Pavle. Gareth is asking, by ping quality speed, do you mean latency or something else?
By ping, yes, we
yeah,
meant
ping quality
latency,
speed.
yeah.
So you talk about latency mostly.
Yes.
Okay. And what could be the possible impact of doing a bulk speed test using a very high number of devices?
So for the bulk speed tests, you would generate a lot of traffic in the network. What also might happen is if you, um, depending on from where do you initiate those tests, for instance, if you initiate it via the ACS, it might also overload the ACS. So there is different things which should be considered when initiating those bulk speed tests. But this is also possible. For instance, we also have solutions for initiating those speed tests and for getting those results. It's only a matter of proper sizing of those solutions so they can take all the load which is needed, which is
Okay,
generated.
thank you. Paulo is asking, are the presented CPE examples integrated router plus ONT, all-in-all devices? Can you get more insight on the health of the network um, based on the KPI delivered by integrated all-in-one CPE with respect to separated routers and
Mhm.
ONT, two separate device scenarios?
So yes, these devices which we tested are actually integrated. So ONTs are within the CPE, and mainly only for such for this option it is possible to get all the relevant information by using the TR standard. For the standalone ONTs, in usually you would need to use SNMP, so usually those devices do not support TR standard, but we would also be able to query them by using this alternative protocol.
All right. Another one. What do you call 26 RX power for ONTRX or LTRX power? Do you call it bad or good based on your experience? Just reading the question.
Hi, so there were some values I didn't get the
I
question.
think it's about 26 RX power
Oh,
for
26. Okay.
yeah for ONTRX or OLTRX power, and the question is, do you consider these are bad or good based on your experience?
So around, so I don't, well, the exact values actually depend on this SFP type, so on the connector type, and also on the CPE model. But I would say that those values between 25 and 30 are mainly fine. Depends. Yet, yeah, this depends on the type of the device. We usually define those thresholds for RX power, between marginal good and bad. They're usually between 25 and 30.
Okay. In any case,
Yeah.
if you have more specific question for Pavle, I'm sure his detail will be in the communication, which will be shared after this session, so you can reach out directly to him. Have another question from the same participant. Is your OLT SFP is C++? I'm not sure I understand the question. Sorry, Pauli. Is your
What is
OLT
the?
SFP classified as C++?
I have it in the presentation. We can have a look at the specific value that was used. So it is, yeah, we have actually different SFP types here, which were used, and then for each type we have different thresholds defined. So these were actually some of the SFP types that we encountered at our customers.
Okay. How does your solution ensure interoperability between different vendor equipment, Pavle?
So interoperability is ensured by using those well-defined standards. So these well-defined standards ensure that you can actually query different different device types by using the same queries. Although there are always some differences. For instance, when you're using TR standard, for instance, you would get for one vendor might disclose RX power like RX power, the other one might just put RX. So there are some specifics that need to be always taken into account. So there is always some some fine tuning related to those KPI names which are used.
Okay. Another question: how can a passive network in FTTX be monitored?
So this FTTX is usually GPON networks or Gigabit Passive Optical Network. So it can be monitored by in this approach of ours without any active probes to be deployed in the network. We are monitoring the network by acquiring parameters which are being disclosed by the network equipment. So we are mainly reading those parameters which are disclosed by the network equipment and then analyzing them.
Okay. Well, the number of questions keep on increasing. I'm just taking probably the last two. Do you include these KPIs threshold into your SLA, service level
Uh,
agreement?
well, we define those thresholds. Well, how we usually do it in the lab environment or when we are testing, when we are first connecting our solution to the system, then we are defining those thresholds. So we have some default values which we use, but in this testing phase, then we are adjusting the values.
Okay. And the difference between RX power OLT and ONT, will this affect the quality? And what is the threshold if it affects the quality?
We have some tolerable difference. I think it's around 10% or so. So there are also thresholds defined for this. I would say it is around 10% that when there is difference between around 10%, then we say that there is some there might be some impact.
Okay. All right. And what is the main reason for errors in the OLT and ONT? Can the SFP temperature interfere with the occurrence of these errors?
Yes, temperature can also occur. For instance, also temperature of the ONTs. For instance, if ONTs are in some closed space, so this is something which which we get from our customers because we are not managing these devices in field. So we rely here on the feedback from our customers. So yeah, for instance, this high also high temperature of the CPEs um, can also yeah be one of the parameters which influences the network quality.
Okay. I think we will conclude the Q&A here. Lots of questions, very precise, very much to the point. I'm impressed that you could address every single of them, Pavle. I wouldn't be able to do so. I would like to thank our audience for that incredible engagement. We had quite a few people on the call today. As I said, replay documents will be shared with you early next week. And do not hesitate, to stay tuned with our series of webinar, because we have another one coming up later in February, which is on the importance of sustainability and how the FTTH Council initiative, the Eco Platform, can help any of your organization move towards a better monitoring of carbon footprint and reduction of greenhouse gas emissions. So totally different topic, but nevertheless a strategic topic as well. So Pavle, thank you so much. I hope you'll see many of the participants of today in Amsterdam during the FTTH conference. I wish you all a very good rest of your day. Maybe Pavle, for the conclusion, I'll leave you the floor for the last seconds.
Okay. Well, yes, thank you. Thank you for the attendance, and hopefully see you on some next event soon.
Thank you very much for you and Axiros, and thank you for your support to the initiative of the FTTH Council. Have a good day. Thank you. Goodbye.
Bye.